Welcome back to 5-5. I knew you couldn't stay away. Today we're looking at the natural log again, that derivative, but we're going to now embed it within some product, some quotient, some chain. Of course we can. Why not? It'll be fun. We'll enjoy it. So f of x equals x to the third times the natural log of x. So a little bit of product rule here. Again, we have two things being multiplied together. X is in both of them. So our first derivative, I didn't give myself much room here today. We're going to have product rule, which is 1d2 plus 2d1, remember? So we have x to the third, our first derivative natural log of x, which is 1 over x. To that we're going to add the natural log of x times the derivative of x to the third, which is 3x squared. From there, we're going to go ahead and clean it up. X to the third times 1 over x. That gives me x squared. I like to bring my 3x squared to the front of my natural logs. That way it doesn't look like one of them is an exponent for that x. So I get my 3x squared natural log of x. This is a good enough answer for me. However, our book will probably go ahead and find a common denominator. Or not common, a common factor. Our common factor here is going to be x squared. So we have 1 plus 3 natural log of x. And that's going to be a nice, clean looking answer, we say. Example 2. Again, we have x plus 2. That's a quantity times the natural log of x to the second. With this one, we can play around with this. Remember yesterday I told you if we have an exponent, we can bring that exponent to the front. Well, actually, this 2, if we brought it to the front, it would be x plus 2 times natural log of x. So that 2, we could actually move all the way to the front of that. And that's kind of the way I like to write it, just because we can kind of put it out here and leave it until the end. So I have 2 times x plus 2 times the natural log of x. So my derivative, again, that 2 is going to, since it's a constant, it's going to float out there until we get done and we have to figure out what we're going to do with it. So we have a product rule. We have x plus 2 times 1 over x. To that, we're going to add the natural log of x times derivative of x plus 2, which is 1. I can go ahead then and kind of clean this up. I have 2 times, I have x plus 2 over x plus the natural log of x. Again, this is an okay enough answer for me. There's not really a whole lot we can do with it unless we wanted to find a common denominator inside here, which would be, since this is over 1, our common denominator would be x. So we could have 2 times this x plus 2 plus x natural logs of x, and it's all over that x. Now, something that I will show you, it's not something that we normally do all the time. Sometimes we do it, sometimes we don't. It just kind of depends on the person that's writing the answer to the question. And that is this here. Remember, if this was a number, if it's anything being multiplied to a natural log or something, this we can write in the exponent up here. So this answer could be written as 2 times the quantity of x plus 2 plus the natural log of x to the x power all over x. Do we normally see it that way? No, we'll normally see it in this fashion up here. But I just wanted to give you kind of a heads up, or something to look out for if you're looking at the answer and saying, hey, how did that number go up there? Well, that's one of our expansion rules for natural logs. We can do that. All right. Well, what about some quotient and some chain rule today as well? So quotient rule, we're going to do just like we did quotient rule before. So our derivative, we're going to have quotient rule, which is our low. So x squared. This 3, remember this 3 we could pull out to the outside. Since it's in the numerator, I kind of leave it in the numerator. So we have x squared times 3 over x will be the derivative of 3 natural logs of x minus 3 natural logs of x, derivative of x squared, which is 2x. And that's all over x to the fourth. Now comes the cleanup. We have x squared times 3 over x. That's going to give us 3x minus 2x times 3. That gives us a 6x natural logs of x over x to the fourth. We can go ahead then and clean out an x, since we have an x in each of our terms. So we have 3 minus 6 natural logs of x over x to the third. Again, it depends on where you want to do, what you want to do. 3 minus 6, we can pull a 3 out of that. So we get 3 times 1 minus 2 natural logs of x over x to the third. Again, this is just kind of cosmetic. Any of these would be acceptable answers. They're all derivatives, but it just kind of depends on where you're going to fall for a multiple choice answer. And again, remember, we could bring this 2 up to the exponent if we wanted to. And then finally, a chain rule. Chain rule. Remember, there's 4 parts to the chain. We're going to bring the exponent and multiply it to the front. So we have 3. The inside is going to stay the same, natural log of x. We're going to decrease the exponent by 1. And then times the derivative of the inside. Derivative of natural log of x is 1 over x. So cleaning this up, there's not a whole lot to do. We can maybe take this denominator and give it to everything. So we'd have 3 times the natural log of x quantity squared over x. And that's going to be pretty much all that we're going to kind of see today. So that gives you an example of a couple of product rules, a quotient rule, and a chain rule using that logarithmic differentiation. So if you have any questions, let me know. Good luck, enjoy, and happy finding those derivatives.